Hi everyone, in this video we are going to learn about consecutive integers. So first off, consecutive integers are integers that are in counting order. So for example, we have 1, 2, 3, 4. Those would be consecutive integers. They just come one after another. We also can say consecutive odd integers, so that would be 1, 3, 5, 7. We're just listing the odd numbers in order. We can also say consecutive even integers, like 2, 4, 6, 8, 10, and so on. So yet again, we're just listing the even integers in order. So when we want to solve consecutive integer problems, our first step is we're going to let n equal this first unknown integer that we're going to be talking about. The second step is we're going to rename each of the other unknown integers in terms of n. So if we're talking about consecutive integers, so like 1, 2, 3, 4, one after another, we'd be saying n plus 1, or n plus 2, n plus 3, and so on and so forth to rename each number. If we were only asked for odd integers, we would be saying n plus 2, n plus 4, because we know odd and even integers are every second number. So that's why we'd be going up in plus 2 every time instead of plus 1 every time. Step 3, we want to write an equation to solve for n. And then step 4, we're going to plug back in to solve for our integers. So let's see how that's going to work. So in this first example, I'm asked to find 4 consecutive integers with the sum of 54. So I first like to find out, well, how many integers am I looking for? So in this case, I need 4 numbers and they're consecutive integers. So that means they're one after another. So remember, step 1 told us let n equal our first unknown integer. So if I need 4 consecutive integers, I need 4 unknowns right now. And I know my first unknown integer I'm going to name as n, because that's our step 1. We're always going to start with our first unknown integer as n. Well, if I want consecutive integers, that means I want one after another. So that means I can write n plus 1, n plus 2, n plus 3. Because let's just say, we don't know what it is, but let's just say n, our first number was 5. Well, 5 plus 1 gives me 6, 5 plus 2 gives me 7, 5 plus 3 gives me 8. And we can see these are consecutive integers. And that would have worked for any number I pick. So we're just renaming these integers in terms of n. So if we have a starting number of n, then we know if we add 1, we're going to have one more number. If we added 2, we would be 2 away, and so on and so forth. So that is now step 2 done. We've renamed each of the integers in terms of n. Now we want to write an equation for our word problem. So our word problem tells us that these 4 integers have to sum to 54. So I know sum means to add. So I can say that n plus n plus 1 plus n plus 2 plus n plus 3 equals 54. All I did was take each of these and add them together. All I did was put plus signs in between, and I said they're going to equal 54. That's how I got that equation. Well, my next step is to now go solve. So, just like normal solving, I need to go combine my like terms. So wherever I see an n, I'm going to go combine that first. So let's see, I have 1, n plus n plus n plus n. That gives me 4n. And then I have 1 plus 2 plus 3 gives me a plus 6 equals 54. Subtract 6 on both sides to get 4n equals 48. And I'll divide by 4 and that should give me n equals 12. So what that tells me is my starting number is 12 because I just found what n is. N is 12. So to find those 4 consecutive integers, I take what n is and then I just go plug them into each of these expressions up here. So I know n is 12, so I know this is just going to be 12. N plus 1, well, that's 12 plus 1 is 13. N plus 2, well, n is 12, so 12 plus 2 is 14. And then n plus 3, 12 plus 3 is 15. So those are my 4 consecutive integers that add to 54. And you can even go check your answer. Does 12 plus 13 plus 14 plus 15 equal 54? Yes, it does. So you know that you are correct. All right, let's do another one. This time I want to find 3 consecutive even integers with the sum of negative 84. So yet again, if I want 3 integers, I like just to draw 3 blank lines up here. And that's going to represent my expressions in terms of n. So remember our step 1. Our step 1 is our always our first unknown integer is going to be n. So I can go ahead and plug n in right in this first line. Well, I want even integers right now. So that means even numbers, I skip a number, right? If I'm counting evens, I'm going 2, 4, 6, 8. I'm skipping those odd numbers. So when I have even numbers, I'm not going to write n plus 1, n plus 2, n plus 3, because I don't want consecutive. I want n plus 2, n plus 4, and you just keep counting by 2s because you're going to be skipping the odd numbers. So now that you have your expressions for the consecutive even integers, you can go ahead and write your equation for this word problem. So you have your 3 terms, and you want them to sum to negative 84. So again, you know sum means to add. So you're just going to do n plus 2 plus n plus 4 equals a negative 84. And I'm just going to go ahead and write that equation out real quick. N plus 2 plus n plus 4 equals a negative 84. Yet again, we're just going to go combine our like terms. So we have n plus n gives me a 3n. 2 plus 4 gives me a plus 6 equals a negative 84. I'll subtract 6 on both sides, so I'll get 3n equals a negative 90. Finish off to divide by 3. Oops, 3 should cancel out. And then n should equal a negative 30. Now remember, that's not my final answer. I'm not just asking for you to solve for n. I'm asking you to find the 3 consecutive even integers. So remember, you need to take this n and go plug it into each of these expressions up here to find that answer. So we know our first term is n, so we know n is a negative 30. Then I have n plus 2, so a negative 30 plus 2 is a negative 28. And then I have n plus 4, so a negative 30 plus 4 should give me a negative 26. A lot of people will tend to go wrong on this problem because they'll say a negative 30 plus 2 is a negative 32. They forget those negatives. So just be careful on that. And then yet again, you can check. Do the sum of these 3 consecutive even integers add to negative 84? Yes, they do. And you can also check, are these consecutive even integers? Are they even and do they come one after each other? Yes, they do. So that means you did your math correct. All right, in this one, we want 3. So I'm going to draw 3 lines here just for my fill in the blanks. Odd integers. This can be confusing for people, but similarly to the evens, we know on our number line it's 1, 2, 3, 4, 5, 6, 7. So if I pick an odd number to start, let's just say 1, if I want to get to 3, I'm still just adding 2. And if I want to get to 5, I'm still adding 2. So to get to my next odd integer, I am just adding 2. So it's going to be the same setup as our evens. So just like here how we added 2 every time, we had a +2 and then a +4, it's going to be the same thing here. So remember, our first unknown is always going to be n. And then if I want the next 2 odd, it's going to be n plus 2 and then n plus 4. Because yet again, if n was 1, to get to the next odd integer would have been 2. And then to get to the next one, that would have been, if I'm in terms of n, that first number, I would have had to add 4. All right, so yet again, now that I have it set up, I can write out my equation. So I want to find the 3 consecutive odd integers with the sum of 141. See, again, sum just means we're going to be adding these and then setting it equal to 141 and solving. So I'm going to rewrite that down here. N plus 2 plus n plus 4 will equal 141. I'll go ahead and combine my like terms. So I get 3n plus 6 equals 141. And then we'll just do our inverse operation. So if I minus 6 on both sides, I'll get 3n equals 135. And then after I divide both sides by 3, I should be getting n equals 45. But yet again, I didn't ask for you to solve for n. I asked you to find 3 consecutive odd integers. So I'm going to take that n and I'm plugging it into these 3 expressions up here for my final answer. So I know n I solved as 45. N plus 2, well, I know n is 45, so 45 plus 2 would be a 47. And then n plus 4 should give me a 49. Yet again, you can check, do all of these sum to 141? Yes, they do. And are they consecutive odd integers? Yes, they all are odd, and they do come right after each other. So good job. All right, this one's going to be even trickier because we're not just finding a sum now. So this time we were given the sum of an integer and then 5 times the next consecutive integer is 29. So right now I'm only talking about 2 integers. So I'm going to draw my 2 lines. Just like always, my first unknown is going to be n. And then I need to determine, is this next one going to be n plus 1? Or is it going to be n plus 2? Well, it's going to be n plus 1 because we're talking about consecutive integers. It doesn't talk about odd or even. So I know this other one is going to be n plus 1. Well, now I need to decode what this problem is asking. So I have my 2 expressions, or my 2 integers, and I'm told that the sum of an integer, so the regular integer is n, and I know sum means to add, and 5 times the next consecutive. Okay, so I can say n, my original integer, plus 5 times the next consecutive. I'm going to write 5 times n plus 1. Just like this. It's going to be 5, and then n plus 1 is in parentheses like this. Because that's going to be my next integer. Equals 29. Well, now I have to go solve. So I'd have to distribute that 5 first. So I get n plus 5n plus 5 equals 29. Combine my like terms to get 6n plus 5 equals 29. Subtract 5 on both sides to get 6n equals 24. Last step will be to divide by 6. Oops, sorry guys. And then n will equal 4. So I know once I know n, I can go take n and go plug it into these expressions up here. So n is 4, and then n plus 1, 4 plus 1 is 5. But let's go check what this question was asking. The question was asking to find the value of the lesser integer. So I know these are my two integers, and the lesser integer is 4. So in this question, 4 would be my final answer. And yet again, you can go check this. Can you check that the sum of an integer, well, we know our integer is 4, and 5 times the next consecutive integer, so 5 times the next consecutive integer would have been 5, is 29. Well, is 4 plus 5 times 5 equal to 29? Well, if we do PEMDAS, we do the multiplication first, so 4 plus 25 equals 29. That is a true statement. 29 does equal 29. So our math is good. Let's try one more. All right, this one says twice the larger of two consecutive integers is equal to 15 less than 3 times the smaller. Okay, so first off, I like to draw my two blank lines where I know I'm going to put in my expressions. And I know my first integer is going to be n. And my second integer, I need to decide if it's going to be consecutive integers, which it looks like it is. I know it's going to be going up by ones. So I'm going to say n plus 1. If it was odd or even, then I know I'm going up by 2, 4, 6, 8, and so on. And I know it's only 2 lines because I'm told it's 2 consecutive integers. So let's decode this now. I'm told that twice the larger. Well, I know that this is the larger integer. Pick any number. Let's just say n was equal to 3. Well, if this is 3, 3 plus 1 is 4. So I know this has to be the larger integer. So twice the larger, I'm going to say is 2 times n plus 1. That's saying twice the larger integer. And then I have, let's see, is equal to, so I'm going to draw an equal sign, 15 less than 3 times the smaller. So 15 less than, I know I'm going to have a minus 15 at the end. And then 3 times the smaller. Well, we know this is the smaller integer. This was our beginning. So 3 times the smaller, I'm going to say 3n. And I don't need parentheses around my n just because it's only one term. Well, now I have my equation set up so I can go ahead and solve. I'll simplify the left by distributing. So I'll get 2n plus 2 equals 3n minus 15. I'll subtract 2n on both sides. So I'll get 2 equals n minus 15. I'll add 15 to both sides to finish off 17 equals n. All right. So actually it looks like in this question, it didn't even specify exactly what it wanted. So if it didn't even specify, I would assume that it's asking for both integers. So to finish off the problem, I'm just going to go ahead and plug those in then. So I solved n was 17. So n plus 1 must be 17 plus 1, so that must be 18. And yet again, like we've just talked about, we can always go plug back in to check. We can see is twice the larger number, so is 2 times 18 equal to 15 less than 3 times the smaller. So 3 times the smaller would be 3 times 17 minus 15. And if you were to do that math out, 2 times 18 gives us 36. And then we can set that equal to, we know 3 times 17 is 51. We'll bring down our minus 15. And then 51 minus 15 is indeed 36. So that is a true statement. Those are consecutive integers, 17 and 18. So we did that problem right. We are good to go. All right, I hope this video helped.